no clock chip setting is recommended, so again, I'll choose that. And then it says, you know, pick some resolutions here. And again, for this video stuff, I've been doing pretty low resolution stuff, and again, I'm just going to say OK here. And now it says it'll start to test your X configuration. Again, I'm just going to skip that because I don't want to go through all that, but I think I've walked you through it enough that the idea makes sense here. So again, I'm going to skip that. And it says, okay, now your configuration files have been written. Take a look at it and make sure that, you know, it does what you want it to do, and certainly check out this readme.config file to get the full explanation of what's going on in there. Okay, so I'll just say OK here. And now X Windows would be reconfigured if I had bought a new video card or a new monitor or something. All right, so let's talk about shell scripting for a little bit now. A shell script is basically like a mini program that's composed of shell commands. Shell commands that we already know, things like cat and useradd are examples of commands that we can use in a shell script to automate some task. And scripts are great for repetitive tasks because then you don't have to remember all the different commands that you need to accomplish some task, and you don't have to type them in. If you're like me, I'm a slow typist, so when I use a script, it saves me a lot of time. We can use scripts for things like backups or starting up your computer or adding users. And actually, there's already a script in place for starting up your computer. So it's good to understand shell scripting because we can write our own scripts to do things like backing up our system, or we can modify scripts that are already in place, like those for starting up your system. And it's good for inexperienced users because if they want to accomplish some hard task, they don't have to know all the different commands for that task if there's a shell script in place that does it. All they have to know is how to operate that little shell script, which is really easy. So let's move over to the Linux screen and do some shell script stuff. So let's start with the fundamentals of shell scripts. We'll learn what every shell script must have, and we'll also learn how to execute a shell script. Now I've created this subdirectory of my home directory called scripts, so we'll go in there to work. Okay, and I've got my Emacs editor down here minimized, and we'll use the Emacs editor to create our shell script. Now let's get a new file going, and remember, you specify that file with the Control-X, Control-F commands, or you go under the Files menu and you say Open File. Okay, and remember, tilde specifies my home directory, so tilde scripts is my script subdirectory, and I'll say tilde scripts, and then I'll specify the name of the file that I want to create, and I'm going to call it demo1.sh. Now every shell script should end with the .sh extension, which just stands for shell. So I'll hit enter here. Now you can see the name of this buffer is demo1.sh. It's a new file. Emacs is telling us that. And Emacs is also smart enough to know that it's a shell script because we called it with the .sh extension. So we'll use the special formatting for shell scripts. Okay? So now every shell script must start with what we call a shebang. And a shebang is just a fancy name for a sharp sign followed by an exclamation mark. And after the shebang, what you do is you put the path to the shell that you're going to use. Now I'm going to use the bash shell. That's certainly the most common shell in Linux, the most common scripting language in Linux, and you know, that's the shell that I'm going to use. Occasionally you might see a script that starts with shebang/bin/sh. But I'll bet that bin.sh is linked to bin bash on your system. No Linux systems use the bin.sh shell anymore. You can determine for certain if you go into the /bin directory and you do a long listing, I bet you'll see that the bin.sh shell is linked to bin bash. Now this is a special line. This is the shebang line. Okay? But any other line that starts with a sharp sign is what we call a comment. And a comment is just a note to the reader, telling them what the script is, you know, maybe how to use it, that sort of stuff. Okay, so this is just going to be a short script, so I'll just write this is a silly script. Maybe in the comments at the top, you would write the author of the script, when it was written, the revision history, when it was modified, what modifications were made, and so on. Certainly, if it's a long script that a lot of people are using, you should definitely have a revision history in there so that if you change the way it's working, that people know that and they can just look in the comments and see that. Okay, so the first command that I'll write in my script is the echo command, which is just a print statement to the screen. So I'll write, you know, this is a script, and everything here between the double quotes will be printed out literally to the screen. Okay, maybe I'll write another echo statement that says, you know, what do you think? Okay, let me put a space in there. And again, everything in between the double quotes will be printed out literally to the screen. Now you can also put a comment on a line with some code if it's at the end of the line. So once that sharp sign happens, then the rest of the line is a comment and will be ignored when I execute the script. Okay, so I'll say this is also a comment. Now when I execute the script, all the comments, this one and this one, will be ignored and all the code will be executed. Okay, so now let's save this file, and remember you can do that with a Control-X, Control-S command, or you can go under Files and say Save Buffer. Okay, so now you can see down here we wrote demo1.sh, so let me minimize this window, and now we're out at the command prompt again. So let me do a long listing in my scripts directory, and you'll see here the demo1.sh program that we just created and wrote, and you can also see over here the permissions for it. Now note that there's no execute permissions set for this file. Okay? Now let me show you two different ways to run this script. One way is you can say bash followed by the script name. Okay, so bash demo1.sh will run the script. If I hit enter, there's the output for the script. Okay, just what we thought it should be. Now another way to run a script, and probably the more common way to run a script, is to say / followed by the script name. Okay, so this works if you're in the current directory. That's what / says. / says specifies the current directory, and then you follow that by the script name. Now if I hit enter here, you'll see that I get a permission denied error. And the reason I get that permission denied error is because there's no execute bits set in this permission string. So let me change that. So we'll change it so that everybody can execute this script. Okay, so I'll do that, and now I'll say / demo1.sh, and now it will actually run. Okay, this is certainly the way that I do it more often. It's probably the way that most people do it more often. If that's your style, make sure that the execute bits are set in the permission string, or else you'll get this permission denied error. Now let's look at my second bash shell script. This one uses what we call variables. Variables are just things that hold data or information. And there's two kinds of variables in some sense. One kind of variable is passed into the program when you run it. For instance, if I type demo2.sh to run the program, and then I put a space and follow that by my name, Perry, then Perry is actually a variable to this program. It's sometimes called a parameter or an argument to the program. And the first argument or the first parameter of the program is referred to as $1 when you're inside of the program. So here, if I type demo2.sh space Perry, then $1 will represent Perry, will be the value Perry, and then this echo statement should print out hello Perry. Okay? Then another kind of variable is what we call a local variable. Now a local variable like here, number 1, is being assigned the value 234. On the next line, the local variable number 2 is being assigned the value 456. Now if I want to add these two things up and then store them in a variable called number 3, I have to use the let command, and then I say let number 3 equal number 1 plus number 2. The reason I have to use dollar signs here is because I want the value of the variable substituted into this expression. Okay, so number 1 is the value 234 and number 2 is the value 456. They're going to be added here together, and the let statement says evaluate that expression and then store the answer in this, number 3. Now if I want to print out the value of number 3 to the screen, I've got to say the answer is number 3 in my echo statement. Okay, again, the $ says go get the value of that variable and substitute that into this expression. If I didn't put the $ there, what would happen is it would say the answer is capital NUMBER3. Okay, it would just be some word that it would print out, and it wouldn't think that it was a variable and that it had to go get the value of. The $, forces it to go get the value of the variable and substitute it in. All right, so let's go out here and run this script and see what it does. Okay, so I'll say /demo2, I'll put a space Perry. Okay, and it says, hello Perry, I hope you're having fun, the answer is 690. And if I did the same thing again and I put a capital P there, then again, the capital P-E-R-R-Y would then be translated to that variable, and that would be printed out to the screen. Okay, so you can kind of see how variables work now. Now let's do a third script, but before we do that, I just want to show you a couple things. Let's make a script that can take a set of usernames and show for those particular usernames how much disk space they're using in their home directory and below. Okay, so remember the du command that we've looked at before. If I do the du command in, let me go up one level here so I'm not in my scripts directory. If I do the du command there, it does this whole listing of stuff. And remember, the du with the -s option does a summary. And so it says there's 1,400 kilobytes of space used in the dot directory, meaning the root directory of where I'm at, the Perry directory. Okay, so that's sort of going to be the essence of our script. We're going to use this du -s command so we can get this information, and we're going to print that out to the screen for each username that's input. Okay, so let's look at the first approximation of this script, and then we'll do another refinement of this script in a second. So now this script uses a conditional statement. Okay, a conditional statement in the Bash shell scripting language is signified by an if